So good morning students. So in this class we are going to determine x of n whose z transform is given as x of z which is equal to log of 1 plus a into z power minus 1. So where modulus of z greater than modulus of a. So with the use of power series expansion for log of 1 plus lambda and log of 1 plus lambda which is equal to summation n which is equal to 1 to infinity minus 1 power n plus 1 into lambda power n divided by n, and lambda modulus of lambda less than 1 if x of z with modulus of a into z power minus 1 and less than 1 can be expressed as log of 1 plus z power minus 1 which is equal to summation n which is equal to 1 to infinity minus 1 power n plus 1 into a power n into z power minus n divided by n, and x of n is reduced as x of n which is equal to 1 by minus 1 power n minus 1 n plus 1 into a power n divided by n into u of n minus 1. And determine whose is the transform as a form of x of z which is equal to 1 divided by 1 minus a into z power minus 1 and modulus of z greater than modulus of a. So with the use of 1 by 1 minus lambda which is equal to 1 plus lambda square plus and so on, and modulus of z less than 1. So carrying out a long division in x of z with modulus of a into z power minus 1 less than 1, where x of z which is equal to 1 plus a into z power minus 1 plus a into z power minus 1 the whole squared plus x of n is reduced as x of n which is equal to a power n into u of n with agrees with example 5.1 and 5.2, and determine x of n whose transform of the function of form of x of z which is equal to 1 divided by 1 minus a into z power minus 1 means modulus of z greater than 1 or modulus of z less than a. We first express modulus of z as, so modulus of z which is equal to minus a power minus 1 into z divided by minus a power minus 1 into z 1 divided by 1 minus a into z power minus 1 which is equal to minus a into minus 1 into z divided by 1 minus a into minus 1 z means. So carrying out the long division method in x of s with modulus of a minus z into less than 1. So if x of z which is equal to minus a into minus 1 is z and 1 plus a into minus 1 is z plus a minus 1 is z in the whole square, and x of n is reduced as x of n which is equal to minus a power n into u of n minus 1 and which agrees the table. And this slide shows the transfer function of the linear function of linear time invariant system, and a ALTI system can be characterized by transfer function, that is which is just a transform expression when starting with modulus of k which is equal to 0 to y and a k j into h n minus k which is equal to summation k which is equal to 0 to n b k into x of n minus k, applying the z transform on this equation with the use of this linearity and time shifting property. We have y of z which is equal to summation k which is equal to 0 to infinity into y of ak into z power minus 1 which is equal to x of z which is equal to k which is equal to 0 to n and bk into z power minus 1. The transfer function denoted by h of z is defined as h of z which is equal to y of s divided by x of z, output divided by input, which is equal to summation k which is equal to 0 to infinity b1 into z power minus 1 divided by summation k which is equal to 0 to n ak into z power minus 4. So the system impulse response as a given by the inverse transform of h of s with an appropriate ROC, that is a transform of all such that y of n is equal to y of n into x of n, and x of is y of z which is equal to x of n including conjugation x of h of n, that is transfer function of the particular solution. So this suggests that we take first care of the z transform from x of n and h of n, then multiply x of z by h of z, and finally perform the inverse transform of the x of z into h of z. And next problem, so determine the transfer function of input and output. Y of n, x of n is the input, y of n is the output are shown in figure, are related. Applying transforming theorem, y of minus n minus 1 plus yx plus x of n minus 1. Applying the transform of the difference equation with the use of and determine the transfer function of ALTI system whose input x of n, output y of n are related by, so y of n so determine the transfer function of ALTI system whose input x of n and output y of n are related by, and y of n which is equal to 0.5 y of n minus 1 plus x of n plus x of n minus 1. So applying z transform on the difference equation with the use of linearity and time shifting properties, h of z is, so y of z into 1 minus 0.1 into z power minus 1 which is equal to x of z into 1 plus z power minus 1 lies between h of z which is equal to y of s divided by x of z. Difference equation with the use of linearity and time shifting properties, h of z is y of z into 1 minus 0.1 z power minus 1 which is equal to x of z into 1 plus z power minus 1 which tends to h of z which is equal to y of z divided by x of z which is equal to 1 plus z power minus 1 divided by 1 minus 0.1 into z power minus 1. So note that are the two ROC possibilities, namely modulus of z greater than 0.1 and modulus of z less than 0.1, and we cannot uniquely determine h of n. And find the difference equation of ALTI system whose transfer function is given by h of s which is equal to 1 plus z power minus 1 into 1 minus 2 into z power minus 1 divided by 1 minus 0.5 into z power minus 1 into 1 plus 2 into z power minus 1. So let h of z which is equal to y of z by x of z performing cross multiplication and the inverse transform we obtain. So 1 minus 0.5 into z power minus 1 into 1 plus 2 into z power minus 1 into y of z which is equal to 1 plus z power minus 1 into 1 minus 2 into z power minus 1 into x of z which is equal to 1 plus 1.5 into z power minus 1 minus z into minus 2 into y of z which is equal to 1 minus z power minus 1 minus 2 into z power minus 2 into x of z. So which lies between y of n plus 1.5 into y of n minus 1 minus y of n minus 2 which is equal to x of n minus x of n minus 1 minus 2x of n minus 2. And compute the impulse response h of n for a LTI system which is characterized by the following difference equation, that is y of n which is equal to x of n minus x of n minus 1, and applying z transform on the difference equation with the use of linearity and time shifting properties, h of z is, so y of z which is equal to x of z into 1 minus z power minus 1 which is equal to h of z divided which is equal to y of z by x of z which is equal to 1 minus z power minus 1. So there is only one ROC possibilities, namely modulus of z greater than 0 only. Taking the inverse z transform on h of z we get h of n which is equal to del of n minus del of n minus 1. And determine the output y of n If the input is x of n which is equal to y of n and the ALTI system is impulse response is h of n which is equal to del of n plus 0.5 into del of n minus 1, the transform of x of n and x of n h of n are x of z which is equal to 1 divided by 1 minus z power minus 1, where modulus of z greater than 1 and h of z which is equal to 1 plus 0.5 into z power minus 1 and modulus of z greater than 0. As a result, we have y of z which is equal to, so x of z into h of z which is equal to 1 divided by 1 minus x power minus 1 plus 0.5 into z power minus 1 divided by 1 minus z power minus 1, where modulus of z is greater than 1. Taking the inverse z transform of y of z with the use of timing shifting property yields y of n which is equal to u of n plus 0.5 into u of n minus 1, which agrees the example. 3.8 equations. Okay, that's all about inverse transform, and so next class we'll discuss the next chapters. So thank you, students.